guys, good day. It's me, Teacher MJ. Our topic for today class, it's all about the rectangle. Finding all sides and all angles. So without further ado, let's do this topic. So this is already part 2 of our video class. The part 1 of our video, we actually solved for this one. Finding all sides and all angles. So given, we have line segment AB. And we have given angle ABD, that is 39 degrees. And you're told to find all sides and all angles. Now this one class, the part 2 of our video, this is actually requested class from our subscribers and our followers. Sir, what if the given angle is in the middle part, in between with this diagonal? So how will you solve finding all angles and all sides? But once again class, do not be worried. We will be explaining this one step by step. Alright, so let's start. We have given BC, that is 8. Okay, this side BC is 8. And side DC is 15. And we have given angle AEB. AEB, that's 124 degrees. And you're told to find all sides and all angles. So let's start first class in finding all angles. Alright, finding all angles. So we have 124 degrees for angle AEB. Therefore, this one is also 124 degrees. So this is 124 degrees. Question, why is that, sir? Because vertical angles are congruent. Alright, vertical angles are congruent. Sir, when do we know that these are vertical angles? Vertical angles, class, are formed by two intersecting lines. So if you have two lines cross to each other, intersecting lines, they form vertical angles. And vertical angles are congruent. Therefore, this angle right here is congruent to this angle. So this angle is congruent to this angle. And this angle right here is congruent to this angle. This is what we call class vertical angles. And vertical angles are congruent. It's like letter X, class. Okay, letter X. So let's draw another vertical lines or two intersecting lines. What if you have two lines like this? What are those vertical angles, class? Could you try that? Yep, that's correct. So this angle is congruent to this angle. And this angle right here is congruent to this angle. So these are vertical angles. If this is 120, therefore this is 120. Vertical angles are congruent. Alright, so this is 124 degrees. This is also 124 degrees. How about this one, class? This angle right here. What would be the measure, class? Now, to get the measure of this angle, you need to recall the straight angle. So if you have a straight line, okay, and the measure for that angle, class, it should be 180 degrees. Any straight line, class. If you have this straight line, it should be 180 degrees. If you have this one, the measure of this angle, it should be 180 degrees. So therefore, if this is 124, the thing that we will do, we subtract this 124 from 180 so that we can get this angle. Because this angle plus 124, that would be equal to 180. Alright, so this will be 180 minus 124. So 180 minus 124. So this will be, so borrow 1. This becomes 7. This becomes 10. 10 minus 4. That is 6. 7 minus 2. That is 5. 56. So therefore, this is 56 degrees. Once again, why is that, sir? Because this is a straight line. It should be a straight angle. And a straight angle, that would be equal to 180 degrees. Same with this one, class. Straight angle. If you add this up, 124 plus 56, that's 180. So therefore, this is also 56. 124 plus 56, that would be 180. Or vertical angles, 56 and 56. These are vertical angles. Alright, so next. Alright, almost done, class. Next, what would be this angle, class? This A and B. What would be this angle right here? Now, recall this one, class, that in a rectangle, there are 4 isosceles triangle. What do you mean by isosceles triangle, class? If you have this line, class, example, class, this one. Okay, if you have this triangle A, B, E, so A, B, E, this line right here, class, this side, okay, this side AE or line segment AE is congruent to line segment BE. Right? Why is that, sir? Because this diagonal AC, class, and this diagonal BD bisect each other. They cut themselves into two equal parts. Okay, they cut themselves into two equal parts. And this diagonal AC and this diagonal BD, they are congruent, class. Okay, once again, if AC is 20, therefore BD is also 20. And if they cut themselves into two equal parts, therefore this AE is 10. Okay, let me just give you an example, class. If AC is 20, therefore AE is 10 and CE is 10, right? And since the diagonals of rectangles are congruent, BD should be 20. Therefore, this is 10 and this is 10. So 10 plus 10, that is 20. 10 plus 10, that is 20. So they cut themselves into two equal parts. I hope you understand this one, class. Diagonals bisect each other. It means that they cut themselves into two equal parts. Let me just draw this one, class, for you to really understand this one. If you have A, B, C, D, and you have diagonal AC, right? When you draw another diagonal, that would be BD, you cut this AC into two equal parts. Okay, so this side, okay, let me just put it here. This AE is congruent to CE. Same scenario, class. If you have this line BD and you draw another diagonal that is AC, you will cut this BD into two equal parts. I hope you understand this one, class. Diagonals bisect each other. At the same time, the diagonals of a rectangle are congruent. So therefore, this will be the same side, right? This side AE, this one, is the same side with side BE, or the same line segment with BE. So line segment AE is the same measure with line segment BE. If this is 10, this is also 10. Now, if they have the same measure, class, if they have the same measure, we call this triangle an isosceles triangle. So once again, class, an isosceles triangle, if you have two sides that are congruent. Another example, class. We have a triangle right here, and these two sides are congruent. Therefore, we call this triangle an isosceles triangle. Now, always remember, class, that in isosceles triangle, the base angle must also be congruent. So this angle right here is the same measure with this angle. Okay? This angle right here is the same measure with this angle. I hope you get this one, class. In isosceles triangle, you have two congruent sides and two congruent base angles. So therefore, this angle right here is the same measure with this angle. And this side is the same measure with this side. This is what we call, class, an isosceles triangle. So therefore, if this is 124 for this one, of course, we know, class, okay, we know that the sum of interior angles of a triangle, it should be 180 degrees, right? Okay, once again, if you have a triangle, any kinds of triangle, class, if it's equilateral, right triangle, isosceles, scalene triangle, the sum of these interior angles, it should be 180 degrees. So since we already have 124, the thing that we will do, we subtract this 124 from 180 so that we can find these two angles, because these two angles have the same measure. So it should be 180, okay, 180 minus 124. So borrow 1, this becomes 7, this becomes 10. 10 minus 4 is 6. 7 minus 2 is 5. 56. Alright, so since these are congruent, therefore we need to divide this 56 by 2. Divide 56 by 2 because we need to get these two angles. And these are congruent angles. So once again, we subtract this 124 from 180 so that we can get this remaining angles. Now, since we do have two angles left, and this angle must be congruent, we divide this 56 by 2. So 56 divided by 2. So 2, 4, 2 times 2 is 4. Okay, subtract 5 minus 4 is 1, bring down 6. 16 divided by 2, that is 8. 28. 8 times 2 is 16. 0. So 28. So therefore, this angle right here is 28 degrees. And this angle right here is also 28 degrees. Alright, so this is 28, this is also 28 degrees. Why is that, sir? Because if you add this up, okay, if you add this up plus this one, if you add this three angles, the sum, it will be 180. So 28, let's add this up, plus 28 plus 28 plus 124. Okay, so 8 plus 8 is 16, plus 4, that is 20. Carry 2. 0 carry 2, 2 plus 2 plus 2 plus 2, that is 8, 180 degrees. Alright, so almost done, class. Now you need to recall, class, that in a rectangle, it has 4 right angles. Once again, a rectangle, it has 4 right angles. Therefore, if this is 28, what would be this angle, class? Because in a rectangle, it has 4 right angles, meaning this angle right here is 90 degrees, 90 degrees, 90 degrees, and 90 degrees. Since this is 28, the thing that we will do, we subtract it from 90 to get this angle. Okay, to get this angle, we subtract this 28 from 90. So 90 minus 28. So borrow 1, this becomes 8, this becomes 10. 10 minus 8 is 2. 8 minus 2, that is 62. 62 degrees. So if you add this up, this will be 90 degrees. If this is 62 degrees, this must be also 62 degrees. Why is that, sir? Because this is an isosceles triangle. This is 10. A while ago, we do an example, class. This side is congruent to this side. Therefore, this base angle must be congruent. This is 62. This must be also 62. Alright? Because if you add this up, it will be 180. Okay? That's the property there for a rectangle, class. Easy, alright? So if this is 62, this will be also 62 because base angles are congruent. So let's check that one, class. Let's add this up. If this is 180. 62 plus 62 plus 56. So 6 plus 2 is 8 plus 2 is 10. 0 carry 1. 6 plus 6 is 12 plus 1 is 13 plus 5 is 18. 180. Alright, easy, right? So if this is 124, check this one, class. This triangle AEB is just the same with triangle DEC. So if this is 124, this will be 28, right? Because 62 plus 28, this is 90. Okay, same scenario with this one, class. If this is 28, this should be also 28. Because this triangle is the same measure with this triangle. So I hope you get the pattern, class, for this one. Or you can do the alternate interior angles. If this is 28, this is also 28. Okay, alternate interior angles. Let me just explain that one. Alternate interior angles. If you have two parallel lines, so you have AB and DC, and it's been cut by a transversal line, so this angle is congruent to this angle. And this angle is congruent to this angle. So this angle is congruent to this angle. So if we cut this one like this, another line. So we cut this one, another line like this. So this angle, okay, this angle right here is congruent to this angle. And this angle right here is congruent to this angle. That's what we call, class, alternate interior angles. And alternate interior angles, they are congruent. Alright, so this is 28 alternate interior angles. Therefore, this will be 62. Okay, this will be 62 degrees. Alternate interior angles. Or, you can add this up. Okay, you can add this up. This will be 90. Because in a rectangle, it has 4 right angles. Okay, if this is 62, this will be 62. An isosceles triangle. Base angles are congruent. That's it, class. All set for the angles. Actually, class, there is a pattern for that one. Just always remember, class, that in a rectangle, there are 4 isosceles triangle. And the base angle must be congruent. This angle right here, base angle, must be congruent. Same with this one. And this base angle right here must be congruent to this base angle. There's a pattern for that one, class. I hope you understand this one, class. Once again, class, if you have some questions with this one, with the rectangle, feel free to leave a comment, class, in the comment section down below. You can always message me, class, in our Facebook channel. Same name with our YouTube channel, class. Feel free to leave a comment, class. You can always ask me, class. Alright, so we're done with all angles, class. Done with all angles. All set. Once again, if you want to name this one, okay, just naming this one, you can have angle CDE. So angle CDE or angle CDB. That's actually the same. CDB or CDE. That's 28 degrees. So always look at the middle part. CDE. So that would be 28 degrees. So you can name it like this, class. Okay? So it's for you to name those angles. So let's find all sides, class. So we have 8 for BC. Therefore, this AD, okay, BC is 8. Therefore, this AD is also 8. Why is that, sir? Opposite sides are congruent for the rectangle. If this is 15 for DC, therefore AB is also 15. Alright, so locking 1 for this diagonal AC. What would be the value of this AC? So let me just draw this up. So let's draw this triangle, class. Let's divide these two triangles. We have ABC and ADC. So let's divide these two triangles, class, so that I can find this diagonal. So let's draw this one. This is, okay, so that I can find this one, class. This is A. Okay, okay, let me just write it in black. So A, DC. So our AD is 8. So this is 8. And our DC is 15. And we're locking this side, class. Alright, we're locking this diagonal. Once again, class, I draw this triangle ADC, this one. Okay, this one, class, ADC. I hope you understand this one. This is 8 and this is 15. So we're locking this diagonal. So what would be the measure of that diagonal? So once again, if you have a right triangle, sir, when do we know that this triangle is a right triangle? If one angle measures exactly 90 degrees, once again, this is 90 degrees angle, that triangle is what we call a right triangle. Okay? So if there's a right triangle, you can always use Pythagorean theorem to find the side. So the formula, that would be C squared equals A squared plus B squared. So our C, once again, plus C is always the hypotenuse, the longest side. So this is the hypotenuse, the longest side. So this is always C. Okay? So we're looking for C. So we're looking for the diagonal. So C, copy C squared equals A squared. Once again, plus for A, you can have 15 for your A, or you can have 8. It could be 8 or 15, class. Okay? For A and B, it could interchange, class. That's okay for A and B. It could be interchange. But for C, it could never be interchange, class. C is always the longest side. Okay, so it could be 8 for our A. It could be 15 for our A. You will have the same answer because this is addition. So let's have 8 for our A. So 8 square plus 15 square. So C square equals 8 square. That is 8 times 8. That is 64. Plus 15 square. That is 15 times 15. That's 225. So C square equals, okay, let's add this up. 225 plus 64. 5 plus 4 is 9. 2 plus 6 is 8. Okay, bring down to 289. Alright, to get the value of C, you extract square root both sides so that you can cancel this 2. The exponent 2, extract square root. And the answer is square root of 289, that's 17. Because 17 times 17, that is 289. Alright, that's the value of the diagonals. So this AC, that would be 17. Now, if this is 17, what would be the value of AE, class? This half. So if AC is 17, half of 17, class. What's the answer? That's correct. It should be, what's the answer, class? Half of 17. That's correct. It should be 8.5. So this AE is 8.5. And this CE is also 8.5. Because 8.5 plus 8.5, that would be 17. Question, what would be the value of BD? That's correct. It should be also 17. Because the diagonals are congruent. So therefore, DE is 8.5. And BE is also 8.5. Half of 17, class, that is 8.5. That's it, class. All set. Finding all sides and all angles. Once again, class, if you have some questions, do not hesitate to ask us. You can always message me in our Facebook channel, same name, with our YouTube channel. Once again, I hope you learned something new today. If you like this video, do not forget to like, share, and subscribe. You share it to your friends and to your classmates so that we can help more students. Once again, class, this is Teacher MJ. You have a great day, class. Goodbye for now. Bye-bye.